Did you know there is a material that fits in the palm of your hand, but can generate energy continuously for more than 15 years? Without sunlight, without fuel, without stopping, not even for a single second? Now let me ask you something. Would you trust a billion-dollar space mission to just 4 kilograms of radioactive powder? Because that's exactly what NASA does, and today, I'm going to show you how one of the most dangerous materials ever created by humanity, a material that was born during the construction of nuclear weapons, ended up becoming the very thing that powers spacecraft traveling to the farthest reaches of our solar system. Now, let me ask you another question. Would you trust a mission that costs billions of dollars to a material that was originally developed during the nuclear arms race of World War II? Because today, scientists and engineers are doing exactly that. And what's even more fascinating is that the same technology that was once created for destruction has now become one of the most important tools for exploring the universe. It all started back in 1940. Scientists were trying to better understand atomic behavior by bombarding uranium atoms with subatomic particles, and during these experiments, they created a completely new artificial element. That element was called plutonium. Just a few years later, it would become the core component of one of the most destructive weapons ever used by mankind, forever changing the course of history. But here's something most people don't realize. There is more than one type of plutonium, and not all of them are used for destruction. In fact, there is a specific isotope that is completely unsuitable for nuclear weapons. Why? Because instead of enabling explosive reactions, it constantly releases heat. This isotope is called plutonium-238. And even though it's inefficient for causing explosions, it is absolutely perfect for generating energy continuously for decades. Now think about this for a moment. When a spacecraft travels to distant regions of the solar system, like the orbit of Jupiter or Saturn, sunlight becomes extremely weak. So, how do you keep systems running? How do you power cameras, sensors, onboard computers, and scientific instruments in an environment where temperatures can drop to minus 150 degrees Celsius and where solar energy is almost non-existent? That's where plutonium-238 comes in. As it naturally decays, it continuously releases heat, and this heat can be converted into electricity using a device known as a radioisotope thermoelectric generator, or simply an RTGTHE. Generators have powered some of the most iconic space missions in history: Voyager, Cassini, Curiosity, Perseverance, allowing them to operate in the darkness of deep space for years without interruption. But how is this material actually produced? How can something this powerful be safely created inside a laboratory? The process begins with another element called neptunium-237, which is typically found as a byproduct in nuclear reactors. In other words, we are essentially recycling nuclear waste. This material arrives at specialized laboratories in liquid form mixed with nitric acid, and the first step is to convert it into a solid. To do that, the solution is placed inside a furnace operating at temperatures above 800 degrees Celsius. The acid evaporates, leaving behind a fine powder of neptunium oxide. This powder is then mixed with aluminum to make it easier to press into small pellets. Each pellet must be nearly identical in size, weight, and chemical composition, because even the smallest variation can compromise the nuclear reaction that comes next after being pressed. These pellets go through strict quality control using lasers, optical sensors, and spectrometers capable of detecting microscopic impurities. Once approved, they are placed inside aluminum tubes designed to withstand extreme temperatures and pressure. These tubes are then hermetically sealed and inserted into a nuclear reactor, where they are exposed to an intense flow of neutrons for several days, and this is where the transformation happens. Neptunium-237 absorbs neutrons and becomes plutonium-238. However, this process also generates dangerous radioactive byproducts, such as cesium-137 and strontium-90, which is why the entire operation must be carried out in heavily shielded facilities with concrete walls more than a meter thick. After irradiation, the tubes become extremely radioactive and must be handled by robotic arms inside shielded compartments known as hot cells. There, the materials go through a chemical process that dissolves and separates plutonium from other waste products using ion exchange resins that act like highly selective filters at the end of this process. Plutonium-238 is isolated in the form of a bright purple powder. This powder is then washed, purified, and pressed once again into pellets, which are heated to temperatures above 1400 degrees Celsius to increase their density and stability. These pellets are then encapsulated in stainless steel containers designed to withstand impact, extreme heat, and radiation for decades before they are ever used. They undergo a series of tests, including X-ray scans, vibration tests, and highly precise chemical analysis. Once approved, these containers are integrated into RTG generators, each one containing approximately 4.8 kilograms of plutonium-238, enough to keep a spacecraft operational for more than 15 years, continuously and reliably, even in the harshest conditions of space. Now, stop and think about this. The same technology that emerged during the nuclear arms race is now responsible for powering robots on Mars, probes that have already left our solar system, and scientific equipment installed in some of the most extreme environments here on Earth, such as Antarctica, or even the ocean floor. Do you think nuclear energy will continue to play a major role in the future of space exploration? Or should we start investing more in alternative solutions? Let me know what you think in the comments. If you enjoy content that shows how dangerous technologies can be transformed into tools that expand human knowledge, make sure to like this video and subscribe to the channel, because here we explore exactly the kind of innovations that have the potential to change the future of humanity. See you in the next video.